Right. Okay. So we're going to start off with this. Delta MC squared. You don't tend to see the delta sometimes. That just means there's mass defect of change in mass. So we can essentially summarize it to be the whole is less than the sum of its parts, or the output is less than the sum of its parts, which is essentially saying when you have a hydrogen, we'll simplify it, so make things as simple as possible, but no simpler. Einstein said that, which is obviously this is from Einstein, yeah? So 1, we'll make it mass 1, that's, you know, hydrogen for instance, yeah? Again, we'll just do a hydrogen here, they'll fuse, so this is the reason they don't fuse in the atmosphere is because they need to go at a very high speed or temperature. They need to be confined in a massive thing like a star, or a very high magnetic field, like in a nuclear fusion reactor. So like they've got one in Oxfordshire and Culham in Oxfordshire, the ITER, and then they've got a new one. They're building a massive one in south of France. That's the ITER, that's the International Thermonuclear Experimental Reactor. The one in Oxfordshire is the Jet Joint European Torus. There's ones all over the place in different places, yeah. But essentially, the clever one is like the one that they've got the fifth fold symmetry that can kind of spin it. Anyway, getting off the point here, so you can look it up in your own time. So 1, they fuse, so they got to go very high speed temperature to get past it. The repulsion, which is, you know, positively charged, they're going to sort of never get anywhere near each other. But then if they go fast enough, they can kind of get past that point, and as soon as they get past this point, they fuse together. When they do that, they produce something that is less than the sum of its parts, so less than 2. The symbol for sum is this one, so it's like it's the Greek symbol equals sum. So like 1, 2, 3, summed equals 6. You know what I mean? So the sum is 2. So we've got sum here minus energy. So we just say minus like it's losing energy. Technically, you know, the energy is still maintained in the universe because it's not gone anywhere. But we just say it's lost energy. So that negative means it's lost energy. So E here is energy, yeah. Joules, yeah. Unit of joules. So this is the energy here. It's a big E, but it's essentially that E is the C. The M is the tiny little bit. So for instance, it could be like 1.99999, you know, but that tiny little bit that change, that mass defect, times when they see the light squared. So C is equal to like roughly 3 times 10 to the 8 meters per second. So times that by itself, so it's 9 times 10 to the 16, is it? That's a big number. It's a fucking big number. So even a small little thing of amount of mass, change in mass, is going to produce a whopping amount of energy. Yeah? So that T equals mc squared, right? So let's take this off. So we'll go like that. Right. Then essentially, this is the fun bit. So this is the thought experiment, which is this is where I thought, like, if James is building a house, so this is James, right? Big hands, because obviously you got massive hands. I've done that retarded, right? 1, 2, 3, 4, 5. Yeah, okay, so so this is James. He's got the ability to clone himself, right? But we got a task for him. So this is scenario A, and this is scenario B. Scenario B is, I haven't got the time to do it like this, but we'll do the same thing. Okay, so there's 2 of them in this scenario B, right? So, so 1, 2, 3, 4. Right. So they're both the same. They should be the same, right? This is the point. They don't look the same, but these are the clones of each other. This is scenario A. I'm asking James to build a house. 1 house, not 2. Yeah, 1 house. 1 house. Now, in this scenario, I'm asking him to build 2 houses. So the average number of houses per James is the same. So, you know, this is the output. I want the output to be 2 houses. I mean, they are the same thing. This is a house. This is a house. So the average house per James is the same. However, the thought experiment is, if I give you how long is it going to take? How much energy is it going to? Yeah, we'll talk about energy because it's got to be an energy. You go, how much energy is James going to use in this scenario to build that house? Is it going to be higher per James to build a house here, or is it going to be higher or lower here? Which one's going to? Is the energy required to build? Even though he's got to build more houses, there's 2 of them, but it's the same number per James. I would argue, and so should you, that the amount of energy used in this scenario is going to be way more than this one. So sharing is caring, you know, mutually beneficial. So in this case here, you'd say being able to share energy. Sorry, share a task. Work done is I think it's force times distance, and that is joules. So it's energy. Yeah. Again, joules is the unit. Of course, Newton's meters. Yeah. Is that right? I'm not sure, but work done is definitely joules. What I'm trying to say is, you've got the ability to sort of like look at this and go, James on his own can build a house. Obviously you can. It's going to take a lot longer and he's going to take a lot more energy. But if we could clone him, and we're just keeping it fair, we're just saying we're cloning him, so he's got himself to work with, I reckon he'd smash this out in probably half the time, less than that even, you know what I mean? So, sharing the workload is caring the workload, if you will. A problem shared is a problem halved, if you will, yeah? So, this is the thought process behind this, which is essentially, you know, what you said before, when we were talking about neurons, or talking about the brain, the whole is greater than the sum of its parts, yeah? It wasn't you that said that originally, it was Aristotle. I mean, it might not have been him, but anyway, the whole is greater than the sum of its parts, or the output is greater than the sum of its parts. Sounds very similar, almost one word's difference from the last fucking thing, yeah? So we'll simplify it to this 1, and we'll put a plus here, plus 1. So this is a guy, another guy, or girl, yeah? You can say the whole is greater than the sum of its parts. So we say for energy related stuff, you know, that sum is here. We'll say the sum, we're going to say plus E, man, because energy is like consciousness. The neurons, for instance, 1 neuron doesn't do much, 2 neurons, yeah. Extrapolate it out to all the billions. Wow, now you've got consciousness, yeah? But we're going to go as simple as we can, no simpler, plus E, so this is the top bit, this is the, and we already know that everything in the material world is made from the factory that is a star, so we'll just say, okay, we'll keep it down here, oh my god, minus E, yeah, so these are the hydrogen, so this is the, you could draw a line like this, and we'll say this below this line, below this sort of thing here, is the material world, and then above this line like that is the spiritual world, if you will, yeah? There you go. You can just say the energy is now simplified in this simple solution. Make it as simple as possible, but no simpler. Inside this, the energy is just gonna, you know, just from here, it's gone up there, isn't it? So it's just pointing up that way. Now I like to draw it like this. And then you could point this as this sort of point in the middle where the conception, you know, links the two, and then it's like a bootstrap. Bootstrapping is like it's a term they use in you know, pulling stuff up by your boots. It's where you start off with, when you want to write a programming language, for instance, when they made maybe the first one, you know, I'll just say for C for instance, C, the programming language C, it was like they use a bit of machine code to write a little bit, and then they use C to write a little bit more, and it kind of worked around, and it's essentially the same thing here. It's like it's gonna like bootstrap itself out, yeah. So that's the growth features. New person there. Anyway, that's your challenge. Wacky Paintings, do this nice and tidy. Again, that's just make it as cool as fuck, yeah. And anyway, if you're watching this and you're not Dio, subscribe to Wacky Paintings and Welsh Nature videos. Cool.